Hello everyone, my name is Steve. I want to welcome you to my YouTube channel. So in this video, you're going to learn how to create your own player missile graphics for the Atari home computer. And the first example I'm going to do is I'm going to show you the display of what the actual character looks like if you're looking at it from a memory perspective. And basically you'll see the blocks and it will be all colored in and stuff like that. And then you'll see numbers and I'll explain the calculations. And then after that, we're going to do some examples on Windows Calculator and kind of see step by step how to make your own calculations. And once we've got the math stuff down, we can move into some fun, throw up some YouTube videos or just some example of Atari videos that are found online and show you how it actually looks like in an actual game. So if those who are new to this will be able to see that. And then after that, we'll move right into some explaining maybe some about the registers and memory and how they're mapped out in the computer. And finally, we'll see the code itself, and eventually we'll be able to run it and see the actual example. Let's move on to the next step. So in order to first understand how the Atari computer represents the graphics on the screen, we need to look at an actual diagram. So this is a diagram I found online of an Atari. It's a spaceship if you look at it carefully. These are little boxes, and each one of these is actually what's called a pixel or a bit. A bit represents a location in memory. And what it does is it takes all these bits and it calculates them into digits over here to the side. So essentially what you're doing is you're looking at it as each one. For example, this could be, well, these are numbered here. I don't have them labeled here, but they're actually numbered 128. 64, 32, 16, 8, 4, 2, and 1 sequentially. And if you take those digits and you add them up side by side, you'll be able to see what they represent here. And I'll show you an example of the calculator here. So let me just kind of do this real quick to kind of narrow this down here a little bit. So we got 128, 64, 32, 16, 8, 4, 2, and 1. These digits represent what's going over here. Look at that. That's pretty accurate. So anyways, over here we're going to calculate each of these rows. So wherever you see the digits highlighted and filled in, we're going to add that number on our calculator. If there's a white space, we're going to skip it because it's not on, it's off. So we're going to skip 32, or 64, 32, and we're going to move to 16. 8 is also highlighted, so we're going to add an 8. And then finally the 1 is highlighted, so we're going to add in 1 to get the grand total sum of 153. So all these digits here represent 153. Now I'm going to open up another calculator here so I can demonstrate how it works in binary. So in binary, each one of these, if it's, as I mentioned earlier, if each one is actually on, that represents a 1. If there's a white space, it's a 0. So for example, you're seeing this black right here, that's going to be a 1. And then we're going to see 2 zeros because we have 2 zeros here. Then we're going to have 2 1s because there's 2 different digits here. And these are going to be zeros. And then finally a 1. So this is the binary equivalent of 153. And how do we know that? If we go over here and actually switch this out. And I think I used the wrong one here. Actually, let's do it on here. Sorry about that. So to redo that here. So 1 0 0 1 1 0 0 1. And then we've changed it over here to binary, or not binary, decimal. You'll see that it actually, I think I started this wrong. Okay everyone, I'm now going to show you how to calculate those values that we saw earlier for the player missile graphics. So 128 plus 16 plus 8 plus 1 equals the 153. Hopefully you can see that there. It's 153. So the 153 corresponds to those digits you saw earlier going from left to right on the screen. And that is how it's calculated on a calculator. You don't calculate the center part where it shows blanks. You only want to calculate essentially what is showing from left to right there. And I'm going to skip into another, swap this out for another picture here to show you something here. Hopefully you can see that. I'm working at a very strange angle, so hopefully you can see this. So anyways, I wanted to point this out to you to show you something important here. So this is the graphic character we're going to be designing for the game. And I demonstrated earlier in showing you that these are the pixels. So I wanted to show you this example, and of course these are the totals down here for what we just saw earlier, 128, 16 plus 8 plus 1 equals 153. And if you just calculate these going forward, this is how you calculate them. You always want to see what number's up here to know what value is going to calculate. So if there was a digit here, it would be 128 plus 64. But of course, there's not. So it would be 128 plus 32 and so on. That's how you calculate them from left to right. And down here, most importantly, this is the binary representation of this picture right here. So you see the ones, zeros, and ones. You notice it's got the same diagram of the picture right here. So I copied that exactly, except I replaced everything here with ones and zeros for the binary. But you look over here and you can see the binary is equaling what we saw here earlier for the other example. And the 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1 equals to 153. So as you see a value like a white space, that's going to be a 0, and red would be the 1s. Basically, that's just how it's calculated in from a binary perspective. And you'll want to know that when you're doing assembly language so that you know how to turn these bits on and off, especially when you're using stuff like masking and stuff like that. When you're setting in clearing bits. So, thank you. We'll move on to the next step. Okay, earlier we saw an example of how to calculate row 1 on a simple calculator, and I also showed you on graph paper how the image looks and how it looks in binary. Now what I'm going to do is I'm going to calculate a few rows, and watch this calculator as we're doing it in Windows 10. You'll see it'll keep track of the binary equivalent. If you look here on the calculator, you can see the decimal is already at 128, and the binary number for 128 is actually the 1000, which is interesting because if you look at this chart right here, 128 is the first digit highlighted, but what this means by 000 means that none of these are actually showing. So right now, if we didn't have any of these, if we had all of these shut off, it would actually be equivalent to what's seen there. So wherever you see the 1, you can kind of think of that as the pixel, and the zeros is the white space. So let's go ahead and start calculating this. So we got 128, and we're going to move into, we'll skip these rows because we did this one earlier. So we did the 153, so we'll move into the 189 instead. So let me just kind of back out of here a second. So 128, got that one. For some reason my calculator's going very slow here. So 128, and the next digit would be plus 32. And then we got plus 16. And you see it as I'm typing them in, it's immediately calculated the next row for us. So if we were actually only had that many digits, you'd see how far it is right now. So we got 16. So the next one is plus 8. And then we got plus 4. And of course, one more would make 189. Let's add a plus to show it to you. So you can see right here the corresponding digits add up. So 128 is what's in that row correctly. The next one is 32. And if you follow that row all the way up, it's 32. So remember, we're doing this row. The next one would be 16. You follow that row up, we got 16. The next one would be 8. Corresponds to 8. And 4. And there's nothing here, so we skip 2. And then we add 1. So hopefully that made sense. I'll probably just do one more example. We did 189. 255 is already pretty... We could do it anyway, but what it's going to do is it's going to highlight all the rows. But watch it as it goes along, and again, you should see what's happening here. Oh, not 255. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And that's 255, because that's basically adds up to 1 byte. 255 is 1 byte. And when you have 1 byte, it means it fills in all the data in that memory section. So I hope this was pretty helpful, and we'll move on to the next tutorial here. Okay, you guys, I'm going to now show you an example of what a player missile graphic looks like. I'm not actually playing the game here. This is just a YouTube video. But kind of demonstrate as I stop and I go through it. Let's go back here a second. This is actually a player missile graphic. It actually could be redefined characters, but I'm pretty sure it's a player missile graphic. So, Mario, as he's walking up the ladder there, and you have watching and everything, he's a player missile graphic there, so he's made up of so many different characters, but he's actually a multicolored player missile graphic. I'm not going to talk about that, but that's basically you had them bit side by side to create other different colors. But I just wanted to kind of show you in this example, this is what a player missile graphic looks like. These little balls moving down here also, these are player missile graphics too, more likely, because you can keep changing. So is the fire. Probably a couple of different things in this could be player missile graphics. Stuff like this could be a player missile graphic. Okay, so I think you guys get the idea. That could be a player missile graphic right too. So anything that's moving over the background there, see how he's moving over the background? That would be what a player missile graphic can do. It can pass over the characters that's already on the screen, essentially. Okay, so before we finally see the code, I'm going to show you some of the registers that will be used in the actual program. And one of the most essential ones you'll notice here is register 106, which actually keeps track of the top of RAM top. Basically, it tells your Atari where the memory begins at, so that you don't end up overwriting things like your display list and other things in memory. One thing you always want to do is you want to make sure that you lower memory while you're setting up the actual player missile graphics here. It's actually known as reserving memory, and you do that just by poking in 106, comma peak 106 minus the number of pages you want to reserve. And you can see an example here. They're just showing in the example there how it works. We'll go over that in a minute. And one of the other registers that we'll use here, get to a second here, is 559. It's also known as direct memory access. So this is actually going to tell you where the computer is going to see the screen at. So if you poke it with 0, it'll actually turn off the screen. And you want to actually use this register. Why? Because sometimes when you're trying to load in stuff, it takes a little bit longer. This is a good register that actually go ahead and speed up the screen display a little bit faster. It actually says that right here. It's handy to turn off the screen when loading and drawing. Turn it back on when the screen is loading so it appears instantly. So that's one of the other registers. And the other register we're going to look at is the color. Starts at 704. We get past the example here. Right here. These are all the color registers. In our in our player missile graphic example, we're only going to use register 704, since we're only going to be turning on the first. We're going to be changing the color of the only one player, which is player zero, excuse me. And it's real simple. You just poke in a value from 1 to 255, and that's going to basically, so as it shows here, holds the background color that's held in by 712. So it's basically going to allow that sprite to appear in the color that you use for that register. The next thing we're going to do here is we're going to basically show you how to position the player on the screen, which is in register 53248 here. It's called the horizontal position, and you can see here values range from 0 to 227. So to kind of get them in the center of the screen, you might want to do something like maybe like 100 or 120 or something like that. So kind of center them where the screen, because 0 will be way off the screen, and then 227 will be way off the other side of the screen. So we'll go over that a little bit more in code. I just wanted to show you the registers, and so that you can kind of see where we're getting this information from. And basically 53240 represents the horizontal position, if I didn't mention that already. So where he's going to position that. Now the Atari doesn't have any vertical positioning, so we'll go over that probably in another video, but you have to kind of position him in memory, where he falls out in memory, basically. So let's go to the next register here, which is, we're going to skip some of these other ones, which these are like the sizes and missiles and stuff like that, but we're not interested in that right now. We're just going to use the ones in the program only, the next one being 53277. What this does is it actually is the activation to turn on the player. So when you put in a 2 here, which is bit 1, it's going to turn on the player. And this is used for missiles. Missiles are just other player missile graphics, allow you to kind of extend the number of player missile graphics you can use in and out. Okay, and finally we have the code, the basic program example that we've been waiting to see. So this is just an example I took from an Atari book that I have called Basic Atari Basic. And I've already typed in the code so you can kind of see, because we already talked about the example, that this is reserving memory. And this is allowing you to make sure you don't overwrite other data or display lists. This we talked about earlier was the most significant byte to poke in from the screen, I'm sorry, from the player, the RAM top where it pokes in the memory. And this is actually turning on the player. This right here is calculating where the position of the Y is going to start. This is what I told you about earlier, where you have to basically, it goes from the top of memory down here to the bottom here, so it's figuring out where in memory this is. So if we run this, I'll show you an example in a minute, and we'll print a J, and I'll show you kind of where that memory is falling at. So the next thing here is we're poking in the values from Y, from J to 255. So what this is doing here is it's poke Y, 0. It's clearing out memory. If you don't clear out memory, you'll get garbage left on the screen here, so it's important to do that. And then finally here, the next thing we're going to do is we're going to poke in the actual display character, or the player missile graphic here. So it reads from Y, which starts at, we already defined Y earlier here when we created the area from memory there. So it's basically, it's represented, excuse me, J here. So it's basically finding where the player starts at, J in memory, adding 120 up to 129. So this is basically taking all these data down here. That's what this read Z is doing. It's reading each one of these in each time into memory. So as it reads it into memory, then we're going to be able to see it on the screen. And then next Y, we'll just go back here and read the next one and so on until it's done. So I'm going to go ahead and run this for now. Now, as soon as I run it, you won't see anything on the screen yet because I haven't positioned the player. I put him at 10 here. I mean, the book shows him at 10, so you won't see him on the screen because they did that so he could kind of scroll on and off the screen. So as I run here, you won't see anything. So you don't see anything yet. However, if we type in this, we talked about this 48, which is the horizontal position, and we move it over, because we notice that 10 right now, to 100, it'll suddenly appear. So there's that whole character we've been waiting on the entire time. Now we also talked about the 704. So if we type in 704 here, and if you want to see what's in there already, you just do a peek. in that memory location. And I'll show you there's an 84 in it. So there's basically color 84, whether the limit is just for that. And then we just go in here, we just type in a different value. You could like increase it by 2 and you'll see it change a little bit. So it changed to like a pink there. Maybe we change it to 100, becomes like a purple. So now you see the character on the screen. And then we also talked about 53277, which turns it on and off. So if we set this to 0, it'll disappear because it's now off. If we set it to 1, it won't appear. If we set it to 2, it won't appear. And of course, if we set it to 3, which is the right one, it'll appear again there. Well, it's already on there. I'm sorry, 2 brought it back, excuse me. So, and we already talked about 54279, so we don't need to mess with that. But what we do want to do is print that J. So 37888 is kind of where this player is being defined. Is where it starts at. Let's go back to the example again real quick. Let's see, it's just too loud. Okay, so 350. So it goes from, that's where it basically ends at. No, I'm sorry, that's where it starts at. And then if we peek in there, we'll be able to see what's in there. Remember the data earlier. Let me just print it out on the screen because I may not just showed up. Oh, actually, let's see. Yeah, that's right. 355. Okay, so where we left off last time is I'm going to show you now. First, I'm going to get the graphic to appear on the screen here. Our player muscle graphic there. I'm going to move it over a little bit more so we can kind of see it in the way there. 40 or something. And then you see these values here. These are the memory locations from where this player muscle graphic or PMG is being drawn at. It starts at 38008. There's a 153. Earlier, remember when we did the chart that 153 defines where the dots are falling at. So we're going to change it with one simple example here. We're basically going to take that and we're going to draw a line all the way across of it. Because remember earlier when we did the 255 on the calculator, it drew a line all the way across, which is basically the center line. So as I hit enter, all's well, it should erase it. There it is. So see how it instantly put the line? We could also do it on the bottom just by going down here at the bottom. And then we'll have a weird looking box. Now we have kind of like a crosshairs or something. So you can see how easily you can go ahead and change stuff. We could also just throw a 0 in here to erase all those lines and do the same thing for the top one. Now we got it kind of back to where it was. If we wanted to change anything else, we would just basically go in and alter these. So look, for example, the center is the 38012. 38012. We could change that out and try to see what we could do really. 16 plus 4. I'm going to see what that's going to do. Oh, interesting. So what it did is it just looked for the 20 in that map and it defined where it was at. So if we just wanted to do the 128 and 129, it'll be on one on the other. So basically it just draws a line split down because it's only taking that line and that line. If you wanted to add the center dot in, you just need to add that extra digit wherever it falls at, whether it's 64 or 32. I think it's 32 probably. No, not 32. We'll take that one back out. Let's try 16. See how it's kind of moving? Basically, you're just defining where that's going to fall at. So there we go. So if you wanted to add them both on, just say 16 plus 8, and then we'll probably have it looking pretty good there. There you go. Looks a little bit different than it did. So you can kind of modify it that way. And all we're essentially doing is we're just modifying this data. This data is just poking this into memory the same way we were just playing with it earlier. Now the last step I want to show you is movement. Run it again. We're going to position it. Now it's going to draw the same graphic character again because we haven't we overrided the data that was already in memory previously. We'd have to change the data statements for it to change to what we had it earlier. So now if you want to move it, remember 53248 is defining where it's going to fall on the screen. So as we move this around, we saw it kind of move around. So if you want to move it, we just set it in a simple loop. I just use equals. We'll just say equals something on the screen at 50. We could just make it go off the screen too. 0 to 160. And you just type in the 53248, A, which is the value that we're going to move. So we're going to move it through an increment values from 0 to 160. And you're going to see it disappear. It's going to redraw it over here, and it's going to move. Pretty fast, actually. So if you wanted to slow it down, you just have to put in like a center loop here. It's called an extra delay, because it doesn't really do anything. It just kind of waits for what you're going to do. And then you can move it. That may have been too slow. Yep, it's too super slow. So you can still see it moving now. Okay, so in the final example, we're going to go ahead and rerun the program again. And we're going to reposition the sprite. And this time we're going to erase the data here with a simple for loop, and I'm going to reposition it here somewhere. Kind of give you an idea of how vertical movement works. So what we're going to do is we're just going to make this really simple. We're just going to say equals 38008 to 38017, so it makes sense. And we're going to put a 0 in it just like we did earlier to erase the data there. Now you'll see it disappear. So it disappeared. And what we're going to do is we're going to reposition it a little bit further up the screen. Maybe we could do it like 16 or something like that. So I'm just going to do some quick calculations here. So if you say like minus 16, we could probably have it start there or something like that. And then plus 16. So let's double check that, make sure that that data matches. 10 bytes. Oh, that's 32. Oh, because I did 16. Okay, so 16 be plus 10, excuse me. It's only 10 digits, so 10. So now we got 37,992 to 38018. And all we have to do is go in here and then type 37,992. We're going to need our data examples. Now I'll type it in 1 bit by bit to show you how it works. 153. You'll see the first there. Now we'll change this to 93, and we'll do, of course, another 153 to get the next row. And then we'll change this again to 189. See how it's redrawing it? It's in a different position, so it's slightly moved up the screen here. We could have probably moved it up further than that, but I wanted to show you that that's how it basically works. And you did already do 189, 95. We know these are going to be 255. It's almost completely drawn now. There it is. I may have messed up something on it, but you saw how it kind of moved it. And if you want to move it, you have to re-erase it and redraw it over and over again, so it's pretty slow to see the vertical movement. But I'm not going to go into that. It'll make the video too long. Maybe we'll go over that another time. I just wanted to show you this for now. Hope you guys enjoyed this video. And please like and subscribe. Oh, there's one other thing I almost forgot to mention, which is the size of the player. We probably should have showed you that one. But so I hope you guys enjoyed this video of the Atari example for player missile graphics, and we covered the following things. We basically showed you how it looks like on the screen first, how it would look like in the pixels, like if you drew it on graph paper. And then after that, we covered, the calculations, how to calculate it and make sure that the digits are appearing right, how the binary looks on it, so you can understand it from a machine language perspective. And then we went and showed you an example of the memory registers. We also showed you the YouTube video that is for the Donkey Kong to show you kind of how the player missile graphics look like when you're playing an actual game. And then finally, we used the Atari emulator to kind of show you the example in code. And I went over a few little examples to show you how to change a few different things to kind of modify the player missile graphic to your own liking. So I hope you guys enjoyed this, and please like and subscribe. This is Steve Morris signing off.